I'm the calculus professor, and today we'll be talking about volumes by slicing. Now let's look at problem number 9. In problem number 9, we'd like to find the volume of the solid whose base is bounded by the curves y equals the square root of cosine of x and the x-axis on the interval negative pi over 2 to pi over 2, whose cross-sections through the solid that are perpendicular to the x-axis are isosceles right triangles. And I've drawn a little figure up here to kind of show what this would look like. Here's my curve on top. This is y equals the square root of the cosine of x. And down here's my x-axis. So my region is right here. It looks kind of like a semicircle. It's not a semicircle, but it's that general shape. And then if I take a cut anywhere along here that's perpendicular to the x-axis, let's say I make a cut right here, then I get this isosceles right triangle right here that's kind of coming out towards me. Okay, so that's the shape that I'd like to find the volume of. How we're going to go about this is we're going to remember our formula that the volume that we're looking for is equal to the integral from a to b of some area function of the cross-section dx. Okay, so the question here is, where am I integrating to and from? What are my a and b? And then what is a cross-sectional area in this case? And in this case, my cross-sectional area is the area of an isosceles right triangle. And we know that the area of a triangle is 1/2 the base times the height. So that will help us as we're moving along here. Also, we need to know, where are we integrating to and from? And I see I'm really integrating from negative pi over 2 to pi over 2 here. I'm moving from an x value to an x value, and I'm cutting all the way. So I start cutting here, I end cutting here, but we also can see this is a symmetric region again. So I could just integrate from 0 to pi over 2 and double it. And I think that that's going to be easy for us when it comes to the integration. So let's do it. So what I'm going to do is, instead of integrating from negative pi over 2 to pi over 2, I'm going to integrate from 0 to pi over 2 and then multiply by 2. Now we need to say, okay, when I make a slice, what is the cross-sectional area? And that cross-sectional area, we said, was an isosceles right triangle, and the area of that is 1/2 the base, which is this length, times the height, which is this length. But those two lengths are the same. So we just have to square that length. So it's 1/2 the base, which is the height of that triangle, but the height of that triangle is just the functional value. So it's just times the square root of cosine of x times the height, but that's the same as the length. So I can just square this dx. In other words, it's 2 times the integral of 1/2 the base times the height dx. So it's just a cross-sectional area. Okay, now that we've got our formula set up, we can do this integration. Right off the bat, I see 2 on top, 2 on bottom. They cancel, and so this is equal to the integral from 0 to pi over 2 of the square root of cosine of x squared is just cosine x dx. Take an antiderivative, and I get sine of x evaluated from 0 to pi over 2. Plug things in. I get sine of pi over 2 minus sine of 0. Sine of pi over 2 is otherwise known as 1, minus sine of 0 is otherwise known as 0, and I end up with my answer being exactly 1 cubic unit, and that is the volume of the shape that I was looking for. So this little object here, whose base is this region and who comes up into these cross-sectional isosceles triangle shapes, its volume is exactly 1 unit.